So now we're going to learn our second method for solving quadratic equations. This method is called extracting a root. Now, it only works in very specific circumstances. It only works when x is in only one spot. So you look at all of our examples, and there is only one x in each of these equations, and so we're going to be able to solve for it by extracting a root. If there had been more than one x, for instance in an equation with an x squared and an x term, we would be unable to use this method. Now, the warning you have to remember is that every time you take a square root of your own volition, you have to put a plus or minus sign in front of it to indicate that there are two possible answers. Now, the first step in solving an equation by extracting a root is to get the part that is squared totally alone. So you notice in the three examples we are going to do, only the last one will you have to do this step, getting the squared part alone. In the others, it's already done for you. So let's look at this first one. We have the squared term alone. That's the first step. The second step is to get rid of the square by taking a square root. So we take a square root of both sides. We get 2x plus 1 on the left and the square root of 5 on the right. And remembering our warning, because we took a square root of 5, we have to put a plus or minus sign in front of it, indicating there are two possible answers. Then the last step is to solve for x using whatever means necessary. So in this case, we are going to subtract the 1. Notice I wrote the minus 1 in front of the square root. It's kind of habit to always put square root terms at the very end of the equation so that there's no confusion about what's inside the square root and what isn't inside the square root. And then of course we want to divide by 2 to get the x alone, leaving us two answers to the quadratic as we expect, minus 1 plus the square root of 5 over 2 and minus 1 minus the square root of 5 over 2. We're going to use the same method on this one. It has fractions, inherently making the problem a little bit more difficult, but the same steps are employed. Get the square root term alone, as it is. Take a square root of both sides. Now, when we take a square root of a fraction, if you remember, we take a square root of the bottom, which is 3, the square root of the top, which is square root of 5, and then because we took a square root, we put a plus minus in front of it. And then we have to get x alone. In this case, that means adding 1/3 to both sides, leaving us with two possible answers, 1 plus the square root of 5 over 3, 1 minus the square root of 5 over 3. Okay, in our last example, we have to actually do that first step, getting the square term alone. So first I'm going to add 16 to both sides. Then I'm going to divide by 2. And now I'm at where I was with the other problems. I take a square root of both sides. I get x plus 5 and twice the square root of 2. I have to remember the plus minus sign. And then I solve for x directly. X is minus 5 plus minus twice the square root of 2. So, in order to extract a root, you have to have a single x term. You solve the squared term, take a square root, and then solve for x.